I want to talk about modular arithmetic and how to lead into a discussion of how we can use it to do various kinds of cryptography. The first and simplest that we'll be talking about is Caesar's cipher. Um, so to begin with, let's assume that we have numbers on the real line here like this. Okay, so here's our real line. And here's the origin right here. Okay, here's the origin right here. And we'll break it up into regions that are 10 wide, like this. And they just keep on going here. Okay. Now, so this will be 0. This is the number 0. Let's say this is the number 9. Okay, this is 19. 29, and so on. So we start at 0 and go up to 9. That's 10 numbers, including the 0 and the 9. Okay, so, and every time a number falls in a region way up here, what I want to do is take that number. So, for example, suppose I have the number 13. Let's say it might appear right here. Here's 13. I want to move 13 all the way down to the number 3 right here. So 13 moves from here all the way down to here. So we subtract 10 from whatever the number is when it appears in here. So 13 minus 10 is 3. Let's say the number appears up here. Let's say it's 23. What I want to do is keep subtracting 10 from this number. So I first subtract 10 and I get 13. But 13 isn't where I want to be. I want to be in this region 0 to 9. So I subtract 10 again, and then I get down here and I'm at 3. So this is what I want. So this is what I mean when I talk about 23 modulo 10 or 13 modulo 10. I mean 3. Now notice that one way we can get this number is by taking the number that we're working with, be it 13 or 23, and dividing that number by 10. So for example, 13 divided by 13 divided by 10 is 1 remainder 3. And 23 divided by 10 is 2 remainder 3. So one way of getting this number modulo base 10 is to divide it by 10 and looking at what the remainder is. And the remainder brings us to the right spot down here. So this is what the basic command mod does. So I have a short program here that does exactly that. Let me pull it in here. Let me do list so you can see what the program is. And you can see it's all of 3 lines. I input an integer, a, and then I use the basic arithmetic command, mod, and I do b is equal to a mod 10. So a is the input, and then I'm doing mod 10, and then after I do that, I print b. So let me try run. Okay, input any integer. Let's try 13. Okay, and I get 3. Okay, let's run again. Run. Try 23, and I get 3. So 13 and 23 are equal when I do mod 10. Now there's another question that we might ask about modulo numbers, and that is, what do we do about negative numbers? So let me erase this, And let's talk about negative numbers for a moment. Okay, let's say that so let me draw my real line again. Here, like this. Okay, I have that. I have that. There we go. And I'll mark that off. Here's 9. And out here would be 19. Here's -9, -19, and -29. Okay, let me write down what those numbers are supposed to be. So here's 0, of course. Here's 9, 19. Here's -9, -19. Now if I look at the modulo operation as taking the number and dividing by 10 and then just taking the remainder. So let's look what happens if we have the number -13 right here. So what happens when we have the number -13? And I want to know what -13 is mod 10. Well, I divide 10 into -13, right? And that gives me 1 with the remainder of -3. I'm sorry, -1 with a remainder of -3. Okay, so -1, 10 goes into that, -1 with a remainder of -3. So according to this way of doing modular arithmetic, I could say that -13 mod 10 mod base 10 is equal to -3. But sometimes I want to do my modular arithmetic. Notice that what happens then is what it does is that it always takes this number, whatever it is, and brings it all the way up here and puts it in this interval right in here that goes from 0 to -9. So the negative numbers then map to this interval, and the positive numbers map to this interval right here. Now, but sometimes that's not what I want my modular operation to do. Sometimes what I want it to do is to take these negative numbers and bring them up and map them here as positive numbers. In other words, I want everything to map to the 0 to 10 or 0 to 9 interval. I want everything to map into here, whether it's positive or negative. So that means this number, okay, doesn't go here, doesn't go here. Where it goes is right here, okay? So how would I write my basic program to do that kind of a modular operation? Well, let's look at that. I have, let me list my program. Suppose what I do is I take the absolute value of whatever this operation is. So for example, I do 20, or let's say I do 25, and I say B equals ABS, absolute value of B, like that. Okay, list. Okay, that looks right. Now run. Input any number. Let me input 23 first. I get the answer 3. Now let me run it again. Run, input -23, and I still get the number 3. So that makes the absolute value operation do what I want it to do here. And that's the kind of modular arithmetic I'm going to want to do for Caesar cipher, which you'll be seeing soon. Till next time.